Today we're going to see how we obtain the transfer function automatically. We're going to use the same example that we used in the previous video to obtain the transfer function manually. So the idea here is we're going to make a bond graph model of the system, and then we will automatically obtain the transfer function to obtain the same transfer function as before. So let's do this. So I'm gonna disappear from here, and then we're gonna go and focus on the problem. We have this accelerometer in here that has this input in here, and it has this housing, and inside the housing there's a little oscillator. So I just have taken that out of here and made it into oscillator here in such a way that we will obtain the transfer function here. So let's concentrate on the example that we have over here. So we need to draw a bond graph model of this, and we could actually draw it on the system itself or outside on the right hand side, now that we already know what the what the steps are. So let's just change colors here to make it a little more dramatic. So we're gonna put the one junction for the motion of this mass, and we could put the one junction here for the. At first, we could do this as a velocity 0, or I would say v could be a velocity function of time. So in here we will do the first elements that are attached to it. Here you have your I element, which is the mass. You have also the gravity as an input, which is mg. And in here you have the source of flow. Yeah, in this case, if it's 0 with velocity equals to 0. And then these are the elements that see this junction. Now we create the relative one. We create the 0, which is going to be the velocity. This would be v sub m, or in this case y dot, and this is going to be v of the ceiling, right? V of the top, let's say. So this would be a one junction that has y dot minus b. Okay, and in here we have the c element, and we have the r element. This is our bond graph model, where c is 1 over k here, and the r element is the value of b. So this is the bond graph model that we could enter into the CAMG software. We don't need to simplify it, although we could, but for the purposes of what we want to do, this is good enough. So I think that we should go to the CAMG software and enter this bond graph model. So I am going to have this model here on the left hand side, and I go to the CAMG window here, and I'm going to create the software here. There we go. So in here I need to put the source of flow. It doesn't really matter. Well, let's just do it from the bottom, just like I was doing it. It really doesn't matter. So this is This is 1 here, and then we have the I element, which is, no, I think I messed it up, because we need we need to deal we need a 1, not an I. So let's go. Okay, very good. Now we need the I element. So in here we connect like that, and then we go and do the 0 here, and then we have the 1. Undo, because this this needs to be a 0, not a C. I don't know what it. Okay, sorry. We need this one here, and now we have the C element. Oh, also I apologize for the, I missed the one junction in here that I had, and then I have to put the C and the R element. Then we're fine, like this. And then we have a 1, and then you have it, the SF, like that. Okay, this is exactly like we have the bone graft model on the left hand side. Now it's in the CAMG software. What is important here is we wanted the force on the damper, so E sub 5 is going to be our output. Force on the damper is the output. So let's just define this in our notes over here to make sure that we are on the exact same page to obtain the transfer function. So we say the force on the damper is the output. Okay, so if we could bring from here to our notes this bone graft model, which we can actually go over here and say do a new, I could actually bring it into my notes just so I have it in here. So right here I can say transfer function that we think. So we're going to put objective, the find the transfer function where the output is transfer function equals, the output is E sub 5, which is the force on the damper, with respect to the input, which would be SE1 of S. So this is our output, and this is our input. So we need to define this E5 as an output. So right now we go back to the CAMG software and we say, okay, look, I need this I need this interface for MATLAB, and then the computer is going to to um, to generate those files. And on the MATLAB side, which we have in here, we have these files that CamG produce. We are interested in the CamG SYM file. This is the file that is important because now in this file we need to define what the output is. So if you go and look for this is E sub 5 is my output, you're going to tell it to make this the official output of the system, and because it has, this is going to be output number 1. We could have more than one, but this is what we want. So this ones that I put in here is to make the C and the D matrix the first row, because that's how CamG works. So in here, if you just run it, okay, you will obtain the state space form, and you will obtain also the B matrix, the D matrix, and this you say, oh my gosh, I have two transfer functions here. Now which is which? And why do I obtain two transfer functions? We obtain two transfer functions because we have one output and two inputs. Let me show you here. The computer program is telling you input number 1 is SE1 and input 2 is SF8. Okay, so depending on what transfer function we want is what we will get here. So the transfer function SF8 is with respect to the housing, which and here you're gonna have this matrix of transfer function. This with respect to the input number 1, which is SE1, and this other one with respect to input number 2, which is SF8. So what we need to do is to actually put the numbers in here, and I think I want to point out to you that we have obtained the transfer function automatically already. But if we want to do tests on this, like a step input, and we want the body plot, we want the root locus plot, we want all these things, we need to put some numbers. So like in here we can put the numbers. What numbers did I put in here? The ones that they gave us. So here we had the value on those numbers was right here. I wrote them down. B2, M3, and K is 5. Okay, so in here you have P sub 2 is 3, which is this one, and then K was 5, right? And I was 2? Yeah? And this K was 5, so C has to be 1 over 5. Okay? And then if you run this, now the computer says, okay, now I have numbers. See, so the matrices are numbers now. They're not symbols anymore. And so is this transfer functions, the two transfer functions in here. And so the computer is going to go and do some calculations in there. Hopefully not too long. There we go. What it did is it went ahead and it says from output 1 to from input 1 to the output. The output is well, this will be from input number 2 to the output. Okay, the computer is giving you the impulse response and also the step response right away for both of them, and then you have also the let me see, we have other plots. We have this one, which is the body plot, and this is the root locus plot. But the important thing is to be able to relate to the input and the output, and you clearly can see that you can do this. Using the transfer functions, we have two other tests that we do. One is for the root locus method, one for the body plot, but that is how you obtain the transfer function automatically, and you can actually get the step and impulse response plot as well as the body plot and the root locus plot. So that's how once you put, so CAM-GSYM is the frequency domain input for CAMG. So in here we go, and let's stop now.